Hi, I'm Trent Radding, and this is a lesson on the law of sines. So, if there are ever any unknown angles or sides to a triangle, then they can be found using the law of sines. And that is the formula A over sine A equals B over sine B equals C over sine C. Note that these top values are all side lengths, and these bottom values are all angle lengths. The law of sines can only be used if you're given a particular set of angles and sides. There are three combinations that will work. The first combination is called angle-side angle, or ASA. In the example here, I used one angle, a side, and another angle. The first step is to find the missing angle by adding together angles A and C in this case, by adding and then subtracting them from 180. So I found them. I added them together, subtracted them from 180, and then put that angle in over there. Now we can utilize the law of sines by plugging in the B length and the B angle into the equation, which I did there. I brought that down there, and I brought the length of 5 down there. And now, since these two angles these two values both have constant values and no variables, we can use that as our constant, which equals 8.3. And what you're going to end up doing is you're going to keep that value in your calculator as you move on to the next steps by using the second answer function. So what you're going to do is you're going to bring those down to find the 8.3 down to find your variables A and C. And then, this is just a simple law of sines formula. Since A is equal to B, these two are going to be equal to each other, and you're able to find those two answers of C and A. The next combination is called AAS, or angle side. I'm sorry. Right here I use one angle, then another angle, then one side. You begin by solving for the missing angle. I added together the two angles, and then I subtracted it from 180, and I found 46, which I put over here. Next, you can plug the values into the law of sines and formula, and you can find the missing ones. So what I was able to do is I found that since these both have values, I'm able to use that as my constant, and I bring that over here, and I'm able to find my two variables here by multiplying this out, and I have A and B. The final combination is called side-side angle, or SSA. It's also called the ambiguous case, because what you can do is this angle right here. I have 12, 10, an angle of 30. I know at the beginning that that this is constant, but this can change. I don't know if this. For all I know, this could be all the way over there, and that could be the 10 could be all the way over there. So I have to test both out. I have my big triangle here, and I also have this smaller triangle right there. So I have to test both out and find the values. So what I'm going to do, what I did is I made that B2, this angle right there, C2, is B2 that covers the whole thing, and my 10 is a constant over there, and my 12 is also. So for my big triangle, I'm going to go ahead and doing the law of sines, and I'm going to use the two that I know, which are the A values, the sine of 30 and 10, and which I find 20 is my constant value. I use that to find the variables of C right there, and I actually am finding a angle of C in this case since it's on the bottom. And what I'm going to do is I'm going to do SOHCAHTOA, and I'm going to find the value of C, and that is the angle right here of C2. Now I'm going to plug that angle in down here in the bottom, and I'm going to be able to do that, be able to find this missing B angle by adding these two together and subtracting from 180. So I do that, and I find the answer was 113.13. And now I'm going to go ahead and put that into the law of sines formula. And so I solve for that, and I find that B2 is equal to 18.39. Now, next thing I'm going to do is I'm going to kind of realize something from up here. I realized that I have an isosceles triangle because I have two 10s here. So whatever value I found for this, which I found over here, the 36.87, it's also, that 36.87 is also the inside angle. So what that tells me is I have a supplement to that. Now I know the supplement to it by subtracting from 180. The 143.13 degrees is what this angle equals. And now since I also know that 30 right there, I can solve for what this angle equals from subtracting from 180. And I'm going to move over to the next page. Okay, so these are my knowns right now. I have a 12, a 10, a 30, and a 143. Like I said, I subtracted and I was able to find that missing angle right here, which is 6.87. I'm going to plug that into the law of sines and make it equal to 20, which is my constant value. And then I'm going to be able to solve for b. And so basically that b length down here. And that comes over to there. And now that really wraps everything up. The key things that you should have learned from this lesson is the law of sines formula, the three situations in which you can use the formula, which is AAS, ASA, or SSA, and how you can find both solutions for the SSA ambiguous case. This concludes the notes, and thank you for watching.